because they have this particular bonding pattern with involving these elements in this pattern, we can say they're going to tend to have certain properties that are similar to each other. It allows us to start organizing some of our compounds a little bit into distinct groups. When we eventually look at the reactions that are typical for organic compounds, most reactions occur at the site of the functional groups. That's what the most reactive part of the molecule tends to be. So you will find a table listing the various functional groups. It shows examples, shows both with a diagram and with a verbal description what the different functional groups are for the different classes. Let's just run through them. Let's start with simple carbons and hydrogens. Found, by the way, in your book on the bottom of page 437. Hydrocarbons. Hydrogen and carbon. We've already talked about the alkanes. They are characterized by the fact that all the bonds between carbons are single bonds. If one or more of the bonds between carbons in your structure is a double bond, then you have what's called an alkene. Change the ANE to ENE to indicate that you have a double bond in there. If it's a triple bond, you have an alkyne, a YNE ending. Alkynes, as in it takes alkynes to make the world work. Alkanes are known as saturated hydrocarbons. For example, ethane, 2 carbons, saturated. If I connect those carbons with a double bond, I find that in order to maintain only 4 bonds per carbon, I have to use less hydrogen. To make the second bond between carbons, I had to lose 2 of my hydrogens. And with a triple bond, using more hydrogen. And I drew it the more common way with the triple bond with the hydrogen on the left, for the left-hand one. What do we mean in terms of saturated? This is not saturated and unsaturated like in the discussion of solutions. Can you dissolve more? It's saturated and unsaturated in terms of, is there the maximum amount of hydrogen attached to the carbons as possible? Alkanes, there's no way you can get more hydrogen on there. With an alkene or an alkyne, you can get more hydrogen on there by breaking the double bond or breaking the triple bond, reducing it to a single bond.
So if it's saturated, it's going to be that 2n plus 2 number then?
Mm-hmm.
So if it was saturated, it would be that 2n plus 2 number.
Correct.
If you had to figure it out.
Unless it's a ring, in which it's just 2n. But now, this is not the way we use saturated and unsaturated when we talk about solutions that we looked at earlier, but it is the way we talk about fats, saturated fats and unsaturated fats. Saturated fats have long carbon chains with all single bonds. Monounsaturated fats have long carbon chains with one double bond. Polyunsaturated fats have long carbon chains with 2 or more double bonds in the chain. Although they don't have triple bonds in the fats. So we have our alkene or alkyne with a double or triple bond. We also can have what are called aromatic hydrocarbons. Now originally the term aromatic was because many of these compounds had distinct odors. Now the chemical definition of aromatic is a bit complicated. we're going to focus on one particular structure that we see again and again in a lot of aromatic compounds. It's called a benzene ring. Benzene ring is 6 carbons, each one with a hydrogen attached. If you look at the way the structure is written right now, each carbon has only 1, 2, 3 bonds. They get their 4th bonds by having double bonds in the ring. So these are also unsaturated. But these double bonds are actually much, much less reactive than the double bonds in an alkene. Now, a simplified structure of this instead of drawing out all the C's and H's, draw the hexagon. And then we have alternating around the ring single and double bonds. The difference between these two, the positions of the double bonds. Turns out in reality, neither one's the best description. In reality, the electrons that make up these double bonds spread all the way around the entire ring of carbon as one continuous ring of electron density. That's often represented by combining these into a structure with a hexagon with a circle in the middle, representing those fused double bonds in there. So that's another way of drawing benzene. And the next structure I'm going to draw, I'll tell you right now, does not exist. If it did, any idea what you might call it?
Peace sign and
No,
carbon.
peace sign is actually
Yeah, that's true.
anyone recognize that symbol in the center?
Nah, it's not for Eve.
Big fine German engineering.
Oh,
This
Mercedes.
is Mercedes benzene.
Is that going to be on the final?
No. Come back to 122, you'll get some more good chemistry jokes. Or somebody may argue, wait a minute, we haven't heard the first good one yet. Right. Now, the other classes involve adding other elements. Alcohols. Replacing a hydrogen somewhere on the chain is an oxygen with a hydrogen, a hydroxyl group. Related to that, ethers